Okay, class, so this is the force table. This is basically what we're going to be using to study vectors this week for lab 3. Now, it's a pretty simple apparatus. All we have is our table here, and you'll notice that there are 2 scales to measure degrees. The bottom one here measures 0 to 360 counterclockwise, while this top one measures 0 to 360 degrees counterclockwise. You'll also notice that in total there are 4 different pulleys. Now all these pulleys will have string connected to it, and these strings lead back to the center pin. Now the goal for this experiment is to add mass on each of these 4 pulleys, and when it's balanced, when the system is in equilibrium, be able to pull out that pin and have the center pin float right above this. You'll notice that if it's not centered on either one side or the other, if there's some error that's included in how you measure, this entire thing is going to slide over to the side that has more force or more weight acting on it. You'll notice also we have our hangers, right? Again, these are 50 grams. And if you were to do this experiment in person, all you would do is add these slotted masses onto the hanger. And once you determine the exact mass that you need, you'd set your pulley to the right angle, and you would just attach this to the pulley, all right? Now, there are a few things to note when you're doing this lab in person. The first one is that there are certain adjusters on the base of this. So you can adjust this if your table is at sort of an angle, right? Obviously, if it's at an angle, you aren't going to get the true value, and therefore the table won't necessarily balance the right way. Equally, you have these pulleys. Now, these pulleys can be adjusted. So let's say, for example, all your pulleys are low, and the one on the left that I just adjusted was super, super high. Then again, you wouldn't get the full force when you add the slotted masses to the pulley, and therefore you wouldn't get the real measurement, and you wouldn't be able to balance it correctly. The system wouldn't be at a true equilibrium. So now this is the experiment with the correct masses on the pulleys. You'll notice this is based on the data table that you were given. At 30 degrees, we have 150 grams. At 100 degrees, we have 200. And at 145, we have 100. Now, when you're doing this lab in person, your goal was to guess and check by trial and error what mass and what direction this pulley had to be at in order to balance the system. So as a quick example, I've used a little less than 333 grams that was listed on the data table. And when we pull the pin, you'll notice it's not quite centered. So we're going to go back and add a little bit more mass and get it perfectly balanced. Let me try it again. And now we see that the system is perfectly balanced in equilibrium.